Hi guys, so welcome back. We are now continuing on with more double integrals over non-rectangular regions. This problem is asking us to evaluate our region of D of the function x plus y dA, where D is the region bounded by the graph of x equals y squared, x equals square root of y equals 0, and y equals 1. So the first thing that I've already done for us is I have rewritten this in terms of y so it can easily graph them. So we get y equals the square root positive negative square root of x, but we're only looking for the region between 0 and 1 for y, so I went ahead and did not include the bottom part of that graph. And then x equals the square root of y, which is y equals x squared, again, because we're looking at the region of the intersection, I didn't include the left-hand side of this. So one thing I will tell you guys is that we could absolutely set this up as a region 1 integration. Region 1, just a friendly reminder, is that when I consider our rectangles drawn here, that they're in terms of x, or they're going to be a vertical rectangle. But in this case here, let's show you an example of a region 2, where region 2 is going to be where our rectangles are going to be in terms of y. And that just means that the thickness of our rectangles, right, the thickness of rectangles are going to be a dy, right? That's what this really is. So let's go ahead and set this up. The first thing we're going to remember here is that since we're going to do it now as a type 2, these first two things are going to be in terms of y, right? So y equals constants. So we always want to make sure that the very first integral that we always write down are going to be our numbers, our values. So remembering that when we're doing these problems, that y is going to be our lower bound and then our upper bound. So when we're doing it with respect to x, it's always left versus right. We just did one of those in the previous videos. So since we're doing it now with y, we're going to go ahead and do y equals 0 and y equals 1, which conveniently for us, they gave us what those things are. Then we have to remember that for the next one, what we're going to do here is we're going to write down equations where it's x equals the equation, right? So I want y's here. I need to have y's for the problem. So the first thing that I'm going to acknowledge here is that when we're doing this, it's always the right-hand curve first, right? So we always want to make sure that we do the right-hand curve initially. So this is going to be x equals the square root of y. And so that's going to be our upper bound, right? Because when you guys were doing this back in AB and BC calculus, when you're finding the area of a curve, and it was always in terms of y, you would always do the right minus the left. Well, that's exactly what it is here. The only difference is that the right curve is going to be our upper bound. And then we're going to, because remember, it's going to be this minus this. And so our lower bound is going to be the equation of x is equal to y squared. So we're going to have our lower bound as our y squared, okay? And then we're going to go ahead and do x plus y, again, with respect to x, because these are x equals, right? And then our constants of the end are going to be with respect to y. So again, setting things up is the most important thing. That's the basics things that we want to make sure that you guys understand, is just to be able to set these problems up correctly. Because the integration part of it's not as bad. So anyways, we're going to go 0 to 1. We're going to integrate this. Now again, friendly reminder, guys, that we're doing these problems that we are with respect to x. So that means that y is a constant here, right? So when we integrate this, we're going to do x squared over 2. And then since y is a constant, we're just going to integrate y as yx. And then we're going to evaluate this from y squared to the square root of y, and then we have our dy function. All right, so it's just really important to take a second and just remember that that's what we're doing for these particular problems. So I'm going to go ahead and integrate from 0 to 1. And again, we're replacing our x's, right? So everywhere we see an x, we're going to go ahead and place a square root of y. So we're going to have the square root of y squared. So we're going to have y over 2, right? Because the square root of y squared is just going to be y. Plus, and we're going to do y times y squared, which is going to be y to the 3/2 power. Okay? Which again, y times the square root of y, which is y times y to the 1/2. It's just y to the 3/2 power. And so we're going to put big old parentheses around that. And then we're going to subtract. And now we're going to put y squared everywhere we see it. All right? So we're going to have a 1/2. Well, y squared squared is going to be y to the 4th. And then we're going to do plus. We'll plug in a y here. We're going to get a y cubed. All with respect to y. So that was a pretty long step for that. So take a moment to slowly go back through this and make sure you understand what we did in that particular problem. And now we have to integrate one more time, right? But that's not going to be the worst part of the problem. So we're going to go ahead and do a y squared over 2 times 1/2 is 1/4 y squared. We get a y to the 5/2. But again, if you're dividing by 5/2, you're multiplying by 2/5. Minus, we're going to do y to the 5th. And since this is going to be times 1/2, we're going to be to the 10th. And then we're going to do a minus, so I'm going to distribute the negative here, y to the 4th over 4. All of that is going to be evaluated from 0 to 1. So all I got to do really here is just plug in 1 to our function and then just evaluate from there, right? So we're left with a 1/4, a plus 2/5, a 1/10, and then a negative 1/4, and then when all is simplified down, we get a 3/10. All right, so we could absolutely have done this problem with respect to x, or our region 1, but again, I just want to show you guys an example where we're doing this in terms of where we start with a region 2. So I hope that example was helpful for you. And again, the only thing I want to just say to you guys is that this may be helpful to write down if you need to, because I keep saying it's in terms of y, or in terms of x for this problem, but remember this is going to be with y's. So we want to be very careful about that. So until the next video, I will see you guys later. Take care.